Hello students, today we'll be studying mechanical properties of fluids and we'll discuss about solid, liquid and gas. Now in solids, the molecules are very closely packed, in liquids less closely packed, and gases very less closely packed. That means these molecules are very close in solids. They're little apart in liquids and very apart in gases. And these property of the molecules make the liquid and gases to flow, and so they are called fluids. Now this distinguishes solids and liquids in a basic way. So all processes occurring in nature, they are mediated by fluids. Now you know that solid can be compressed, liquids can also be compressed, gases can also be compressed. Now this compression of gases is very large than liquids and it is greater than solids. Now shearing stress, it's a force per unit area of, and the shearing stress of fluid is a million times less than a shearing stress of solids. So pressure is equal to force per unit area. So for a fixed or constant force, the greater the area, the lesser is the pressure, and lesser the area, the greater is the pressure. That means if area increases, the pressure, area is in the denominator, that means the pressure decreases. If area decreases, the pressure increases. So let us now imagine, or let us think about a ball which is submerged in a bucket which is a fluid with fluid. So we can see that ball that is immersed in that fluid, this fluid is exerting pressure which is normal to its surface. Now if the force is parallel to the it means therefore there is no force on the object which will keep it moving. Now the force is resolved into two components. The horizontal component is F cos theta and vertical component is F sin theta. This force is making an angle with the horizontal surface, that is theta. So this component F cos theta of the force will act parallel to the surface. That means if this component gives a force parallel to the surface, the object will also exert a force parallel to the fluid. Newton's third law. See, this is the ball. It is exerting a force parallel to the surface. That means it is likely to happen this will also exert a parallel force parallel to the surface. That's why it obeys Newton's third law. But since the fluid is at rest, this cannot happen. Why it cannot happen? The fluid exerts a force which is perpendicular to the surface. It doesn't exert an horizontal force. Let us discuss this. See, the component F cos theta is acts parallel to the surface, and F sin theta, it is acting perpendicular to the surface. Now, since the fluid is at rest, this F cos theta, it acts parallel to the surface. Here, the theta is the 90 degree. That means F cos theta 0. It will be 0 because I have already told you that it is acting parallel to the surface. So F cannot be 0. Cos theta will be 0. So therefore, theta is equal to cos inverse 90, and what remains over there is F sin theta is 1. Now let us see these devices to calculate the pressure in a fluid. So a fluid is filled in a bucket, a cube is there. We can see with that arrow that it is exerting force from all its sides. This is perpendicular. Now this is an ideal device for measuring pressure. This is the piston. The force is applied on the piston. This is the area. Now this small opening in the cylinder, that is del A. The area A is very small and it can be reduced to very small. So we can take it as delta A. Okay. So that means A tends to 0. Delta A tends to 0. So pressure is equal to force per unit area. So limit of del A tends to 0 is equal to del F by del A. This is the limiting value of pressure. And this is how pressure is defined in its limiting sense. Okay, pressure is a scalar quantity, I told you. It has a magnitude, it has a direction, still it is not a vector quantity. Its direction is not specified. It acts in all direction. We've just seen it, that when a ball is submerged in water, pressure acts in all direction. Thus, it has no specified direction. Okay, so it is a scalar quantity. You must remember it. Okay, fine. You should not forget it. It is that component of the force we have just seen, that it is that component of the force which is acting normal to the area. The F sin theta we have seen, and its dimension, if you want to calculate, its dimension is m L to the power minus 1 t to the power minus 2. How it comes? So pressure is equal to F by A. F is equal to mass into acceleration. A means length into length. So acceleration is again, velocity by time. So replace A by V by T. Again, replace V means velocity is distance by time, x by t. So what happens? In the numerator we get m into x. X is the distance. It can be expressed in terms of L. In the denominator there is t square and L square. So this x and one of the L in the denominator cancels out. What remains is only one L in the denominator, and it goes up ml to the power minus 1, and t square in the denominator goes up to form t to the power minus 2. Now common unit is that atmosphere we can write in atm. So pressure executed by atmosphere at the sea level is the 1 atm, which is equal to 1.013 into 10 to the power 5 pa, the Pascal. In CGS unit, it is dyne per square centimeter, In M case or the SI system, it is Newton per square meter. So 1 Newton per square meter gives you 1 Pascal, which is equal to 10 dynes per square centimeter. Now there are some practical applications of pressures. Now a surf needle, passes very easily because the area at the tip is very small, and hence the pressure needed is very small. A camel works easily on sand. It has a large area under its feet, so pressure exerted becomes less as area in the denominator becomes high. A sharp knife cuts better. The same thing, its cross section of a sharp knife on the cutting edge is less than a blunt one. So force per unit area, when the force is fixed, area comes down, area goes below. So the pressure automatically increases if the denominator decreases. So railroad tracks, they are laid on wooden or iron sleepers. It increases the surface area. So under heavy load, it does not go down. The two thigh bones of human body, each of cross section area 10 square centimeter, which supports the upper part of the body of mass 40 kg. Estimate the average pressure sustained by the femurs. So even a given cross section is given 10 square centimeter for a single thigh bone. So there are two thigh bones we have. So you can multiply 2 into 10 square centimeter. This gives you 20 square centimeter. Now you have to change it into square meter. So multiply it by 10 to the power minus 4. Very easy. Now again, the mass is given 40 kg. So you have to transfer into force is equal to mass into acceleration. So this 40 kg into 10 meter per second square gives you 400 Newton. So average pressure is simple pressure is equal to force per unit area. It becomes 400 Newton by 20 into 10 to the power minus 4 square meter. This gives you 2 into 10 to the power 5 Newton per square meter. Thank you. If you like my video, then please give a like, thumbs up, and subscribe to my channel. Okay, very much.